Good day. In this particular video, we will be discussing another sample problem using nodal analysis. But this time, we will consider a circuit that involves a dependent source. Let's start. So let us consider a circuit that involves a dependent source as shown. Suppose we have the following given. We can observe that in this particular circuit, we have a dependent current source that is dependent on a current Ix that flows on the 4 ohm resistance. Suppose we are interested in solving for the value of Ix. What would be the process in solving for Ix using nodal analysis? Our solution will of course start with identifying our reference node and the node voltages. So in this case, we have two node voltages. We have the VA and the VB. And the bottom node, we will be using that as our reference, which means it is the point of zero potential. Since we have now established that we are to solve for two node voltages, VA and VB, we can now start applying the direction of the currents. So we have three, I1, I2, and I3. And since now we have that current, we can now apply KCL at nodes A and B. So apply KCL at node A. So first, we have I1 entering that. We also have Ix and we have I2 and we have 2 amperes being involved in node A. So since I1 is entering, so that's positive. I2 is leaving, so that's negative. Ix is also leaving, so we will have it negative, and the 2 amperes also leaving, so negative 2 minus Ix equals 0. So that is now our equation. So now we will express this branch circuit current in terms of node voltages. So we can start with I1. So I1 is flowing from the 10 volt source to VA. So we have 10 minus VA over 2. We have I2 flowing from VA down to the reference node, passing through the 1 ohm resistance. So we have VA minus 0 over 1. Just copy the negative 2. And then for Ix, we have Ix is flowing from VA to VB, or node A to node B. So we have VA minus VB over 4 equals 0. We can observe that the LCD is 4. So we just have to multiply it by 4. So 4 over 2 is 2 times 10 is 20 minus 2 VA. 4 over 1 is 4 times VA is negative 4 VA. 4 times 2 is 8, and then 4 over 4 is 1. We just have to multiply it. Okay, so now we just have to combine similar terms and then simplify this equation. Rearranging the equation, we have 7VA minus VB equals 12. This is our equation number 1. For us to derive another equation, we will apply KCL at node B. So apply KCL at node B. So we have 2 entering. And observe that we also have 2Ix, so negative 2Ix. We have I3 leaving, so negative I3. We can observe that Ix is also entering node B, so therefore we have another 1 plus Ix equals 0. We can observe that we have 2 Ix and Ix in the equation, so we can combine them to become negative Ix. And then rearranging the equation, we have Ix plus I3 equals positive 2. Now we can express this in terms of the node voltages. For Ix, we already established that as VA minus VB over 4. And for I3, it flows from the node B down to the reference node. So we have VB minus 0 over 2, or simply VB over 2. And copy 2. The LCD is 4, so we multiply it by 4. So we have VA minus VB plus 2VB equals 8. Simplifying the equation. Combining similar terms, we have VA plus VB equals 8. This is our equation number 2. Now that we have two equations, we can solve for VA and VB by using method of elimination and substitution. We simply add the two equations to eliminate VB. So we have 8VA equals 20, VA equals 20 over 8, and VA equals 2.5 volts. Now that we know VA, we can substitute that back to equation number 2 to solve for VB. VB is equal to 8 minus 2.5 or 5.5 volts. Now that we know VA and VB, we can now solve for Ix. Ix is, we know, is equal to VA minus VB over 4. Substituting the values, we have 2.5 minus 5.5 over 4. So Ix is equal to negative 0.75 amperes. So this is our final answer for this particular problem. So let's recap. In order for you to analyze circuit using nodal analysis, the first step is for you to identify your reference node and label your node voltages. Then apply KCL and the respective non-reference nodes, and then express those KCL equation in terms of node voltages, and then use algebra to solve for node voltages. And then once that is done, you can now solve for your branch circuit currents or branch circuit voltage or power, whichever the problem requires. So thank you so much for listening, and God bless.